Hello everyone, this is G. Karthik Reddy, working as Associate Professor, Department of ECE, MLR Institute of Technology, Hyderabad. Topic is Total Probability Theorem. This is an overview of the contents. Let's start with the introduction to the probability. What is Total Probability Theorem? Mathematical formulation, visual representation, example problem related to the Total Probability Theorem, and the solution approach related to that problem, and finally the application of total probability theorem. Probability. What is the definition of probability? Okay, definition of probability is decided based upon the particular event. Probability of a particular event is equal to total number of possible, okay, here number of favorable outcomes. Number of favorable outcomes of a particular event by total number of possible outcomes This is a basic definition. Next, basic concepts. To understand the concepts of total probability theorem experiment, we need a random experiment. We need a sample space, we need events. What are the different types of events? Next, importance of probability in various fields. Okay, it is helpful in the statistical field, it is helpful in the financial field, and it is helpful in the engineering field. We are measuring the likelihood that an event can occur. It is discussed based upon the probability concept. What is total probability theorem? Why we are using total probability theorem? Okay, why we are using definition tells that it is a rule relating to the marginal probabilities to the conditional probabilities. Okay, next, it is used to compute the probability of an event based on conditional probability. Essential in a situation where events are not dependent. This is very important. Where events are not dependent, during that situation we are using the total probability theorem. What is total probability theorem tells that? Okay, content we are going to discuss. If you are having a sample space, okay, in the sample space you are having, this is a sample space. In the sample space you are having different set of events. Let us consider that B1, B2, B3, so on up to Bn are mutually exclusive events. For example, this is B1, this is B2, this is B3, this is B4, this is B5, this is B6. Okay, we are having set of all the elements. Okay, this set of all these elements represents a sample space. For example, okay, I am representing in general case Bi intersection of Bj is equal to sample space. Okay, you are having collection of all these are mutually exclusive because these two are the disjoint sets. B1 intersection B2. There is no overlap between them. Therefore, there we are having the, what is that? There is no overlapping between them. This is called null set. And B1 union B2 so on up to Bn represents sample space. You can see from the figure that B1 union B2 union B3 union B4 union B5 union B6 represent complete sample space. Okay, B1 intersection B2 or B1 intersection B3 represents the null set. There is no intersection between the elements. If this is the case, and if the probability of P of A is existing in between this portion, okay, we are going to find out the probability of event A. What is the probability of event A? We are going to discuss here. P of A represents P of A intersection B1 plus P of A intersection B2 plus P of A intersection B3 so on up to P of A intersection Bn. Okay, simplified form. You know the definition of conditional probability. What is the definition of conditional probability? You know the definition of conditional probability. P of A intersection B, which is equal to P of B into P of A by B. Okay, this is one of the condition. Same thing I have represented, P of B1 into P of A by B1 plus P of B2 into P of A by B2, so on up to P of Bn by P of A by Bn. Okay, this is a simplified form, and here P of A represents total probability of event A. Okay, we are calculating probability for particular event, and P of Bi represents probability of each portion of event Bi. Each portion of Bi is a partition of that. P of A by Bi represents the what? This is a conditional probability of A given Bi. Denominator portion is the given part and numerator portion is the unknown portion. In detail, we will discuss same thing in Venn diagram. Venn diagram represents the partition of the sample space. Here we are partitioning the sample space. Okay, here we are showing the B1 to Bn covering the events, covering the entire sample space. Covering the entire sample space. A1 intersection B represents this part. A1 intersection B represents this part. A2 intersection B represents this part. A3 intersection B represents this part. And A is a common for all the B events. A is a common for all the B events. When you sum all this, which concludes sample space S. Now, we will discuss with one example. Read the question. A company has two machines. Given data, you are having two machines, machine 1 and machine 2. Okay, here I will define with the events B1 and B2. Defining the events, B1 represents product from machine 1. B2 represents product from machine 2. And what is the common factor of both? Defective product. Defective product from B1 and defective product from B2. What he want to calculate? Probability of a defective product overall. We want to calculate the defective product, which we represented with an event of P of A. Okay, which we represented with a. Then what is the definition? In previous slide we discussed P of A is equal to P of B1 into P of A by B1 plus P of B2 into P of A by B2. We are having only the two machines. Then use that formula. Okay, P of A is equal to P of B1 into P of A by B1 plus P of B2 into P of A by B2. Okay, here P of A is the, what is that? Defective part in both the machines. So what is the total defective? P of B1, what it is given? P of B1 is this one. Okay, I am taking in terms of value 0.7, and P of B1 here you are having 0.3. Okay, now next 0.7, 0.3. Now A by B1 defective from machine 1, that is 0.02. It is appearing here. Now next B2 means defective from machine 2. Machine 2 means 0.05. Then what is asking? What is the probability of a defective product overall? What is the defective? That is P of A. Then if you calculate that, you will get 0.029. And here we are taking the percentage in terms of values. Again you multiply with 100. 0.029 multiplied with 100. Again it results as 2.9%. The total probability of a defective product is 2.9%. Okay, this type of problems you have to do that when there is a common portion. Okay, that part only I am going to discuss. This is a common portion. Which you are having, that is a defective part. Defective part is a common portion, and with this defective part we are having from machine 1. They are discussing, it may be any number of machines, machine 2, machine 3. Likewise you can have, okay, whenever you are having common factor from all the different events, then you can use the approach of total probability theorem. What are the applications? What are the applications of total probability theorem? When we have to use this total probability theorem, okay, when there is a risk assessment and management in finance and insurance sectors, during that time we can use the application of total probability theorem. And we can use for the reliability analysis in engineering. We can use for checking the various applications, we can use this total probability theorem. For medical testing and diagnostic probabilities. For medical testing and diagnostic probabilities also, we can use the approach of total probability theorem. And we can also use for decision making in business and economics. Because in all the factors or in all the applications, there is a common factor. Okay, there is a one common factor that they are having B1 to Bn. You are having n number of events. It may be the testing of the medical test. For example, if you are taking the example of medical testing, okay, B1 to Bn are the n number of cases available, and there will be a common factor that to identify the disease or some virus. Okay, you are having the virus, so that you can identify or diagnostic easily by using what is the amount of probability of that particular case or is defective, or particular case having certain virus or some organs. Okay, we can discuss along with the decision making in business based on different parameters, based on common parameter you are having. Based on the common parameter, we are going to identify that. And reliability analysis also we can use by using different statistical analysis. You can easily calculate the what is the amount of probability occurring for that particular parameter. Even you can use for risk assessment and management in finance and insurance. For finance and insurance, for different financial statistics, we can easily observe that what is the amount of risk you are getting for that particular event. This is related to this. Thank you very much.